Alright, today we are going to be looking at the blending model. Actually, this is actually a standalone tutorial, because if you actually did not go through the previous tutorial, you can actually follow this one because we are starting to solve this problem from beginning to the end. But if you have the time, you can also go through the previous tutorials, tutorial 1 to 5, where we solved the diet problem. Today is going to be the blending model problem. So remember to subscribe by clicking on the subscribe button below, and so that you get notifications when I make new lessons. In this way, you also encourage me to continue to make this lesson for you. If you also have challenges, or you have some questions or some problems you have on some topic you want me to teach, also let me know in the description box. All right, let's see what the blending model is all about. So the blending model has to do with a farmer that has livestock and needs to feed the livestock. He can choose between one of two feeds, feed 1 and feed 2. And he's also considering 3 different nutrients for his livestock: feed nutrient A, nutrient B, and nutrient C. He has to choose to buy some feed 1 and some feed 2, which come in different prices. So what is the problem? The problem is how much of feed 1 and feed 2 is he going to buy for him to minimize his costs. So in most of the time in linear programming, we're always talking about minimizing the cost. So just like we need to set up the cost function. Let me take my pen. So you need to set up the cost function. That is a step 1, because this is a function you need to minimize. And the next is to find out what is the objective of the problem. Is it to minimize? In this case, it's to minimize costs. Later, we can see problem of maximizing some value or some function. And then we need to find out the variables, the unknowns, which are in this case, is the quantity of each feed to buy, quantity of feed 1 and feed 2. We'll set it up in the next table and then we solve it. Then the constraint is there's minimum daily nutrient requirement for the livestock. So in this case, unlike the diet problem, we are going to set up this table ourselves, because in most of linear programming problems, you are given word problems, so you are able to set up the table based on the information provided in the write-up. So let's set up the table now. So this is a blank one. The first thing I would like to do, permit me to end this presentation so that we can actually keep. So let's do it from here. All right. So because I need to be looking at the question and setting up the table. So in this case, the table has been given to us. So let me grab a pen. So we need to, in the table, we must have feed, and we also have nutrients. All right, so let's draw this. Okay. All right, so we have feed 1. Let's just call it 1, and then feed 2. Right? That is fine. So cover all this. So you have nutrient A, you have nutrient B, you have nutrient C. Okay, and here you have the prices. So let's call this minimum daily requirement comes here. All right, so for feed A, you have 3. For feed 1 you have 3, and for feed 2 you have 2. Okay, so for feed B you have 7 and you have 2. For feed C you have 3 and you have 6. So these are quantities of nutrients being bought. So quantity of feed 1, he buys 3 units of feed 1, and 3 units of feed 1, 7 units of feed 1, and 3 units of feed C. So what the table is saying is that 3 units of feed 1 contains a amount of nutrient. Sorry, let's get it straight. Here says that feed 1, right? So 3 units and 3 units of feed 1 contains A nutrient, 3 units of feed 2 contains B, and 3 units of feed 1 also contains C nutrient, and the price of this is equal to what? Is equal to 10. I think this will become clearer. The price of all of these is equal to 4. For nutrient A, the minimum daily requirement for the livestock is 60 units. For nutrient B, the minimum daily requirement for the livestock is 84 units. And for feed C, the minimum daily requirement is 72 units. So this is how to set up the table, right? Good. So the next thing we want to determine is the variables. So the variables, let's write it out here. That is the first thing you want to determine. The variable is, from the question you can see, we are trying to find out what quantity of feed 1 and feed 2. So the variable is feed 1 and feed 2 because they are unknown quantities. So let's call it x and y. So feed 1, let's call it x. Feed 2, let's call it y. Okay. All right. So let me just put in brackets so that it will not be confusing. So x is the amount or quantity of feed 1, and y is the amount of feed 2. So this is our variables. What is the next thing we are going to set up is a cost function. The cost function is a function of what? The cost function is a function of the variables. So of course it always has to be a function of the variable, and it goes this way. The price of 10 units of x and 4 units of y. So 10 units of x and 4 units of y. So this is a cost, and we are going to minimize this. I hope it's clear so far how to set up the table and how to determine the cost function from the table, and also how to choose your variables. All right. So the next thing we are going to do is to determine the constraints. Is to determine the constraints. How do we determine the constraints? The constraint comes from the minimum daily requirements. So for A, it's the minimum is 60, right? So for A we have the minimum is 60, so we have 3x plus 2y, 3x plus 2y. The minimum is 60, so it has to be greater than or equal to 60. I hope this is clear, because it has to be greater than or equal, because 60 is the minimum. So for nutrient B, we have 7x plus 2y has to be greater than or equal to what? 84. And for C, we have 3x plus 6y has to be greater than or equal to what? Equal to 72. So we've done all the setup. So let's call this C1. Let's call this constraint C2, and let's call this constraint C3. So this is actually how to set up the linear programming model, or the linear programming function and as well as the constraints. So at this point, we are ready to start solving the problem. Also, we are going to use the graphing method. I use the graphing methods in the diet problem that I solved in tutorial 3 and 4, or 3 to 5. So we are going to use the graphing methods. Alright, so having done this, I'd like you to spend some time to understand what is happening here, and then we continue in tutorial 7 to be able to solve this. I'd like to thank you for viewing and also give a reminder for you to subscribe to my channel if you have not subscribed. And also, if you look at the description box, you'll see some links to where I make programming tutorials, data science tutorials, machine learning and database, and many other things you'd like to learn. So they are there in the description box, and also links to all the tutorials on linear programming is also provided in the description box. So feel free to leave me a comment if you have any observation or you have any challenges with learning this.